So we're going to be talking about parallel lines and transversals here. Here's a set of parallel lines, and I'm going to draw a third line across them, and this is called the transversal. It comes across the two parallel lines. Now I'm going to draw another one down here. Two parallel lines and a transversal. Now the reason I've drawn two copies here is because this is the version that most people see a lot of the time, and then they get the idea that it only ever looks like that. But the parallel lines can be drawn in any direction. They can be drawn like this, or like this, or like this, or like this, and the transversal can be any angle at all, and all of these rules will still apply. Alright, let's jump into it. Now the basic idea is that if I tell you any angle at all between 1, 2, 3, 4, 5, 6, 7 and 8, if I tell you any one of those angles, you'll be able to find the other 7. So I'm just going to call this one angle A. Now if I call this one angle A, now you can probably see that you can already find quite a few angles without knowing much about parallel lines. Just ignore the bottom parallel line here, and if we just focus our attention up here, we can see that this is going to be A because they are vertically opposite. And we'll just call this, actually this is going to be 180 minus A because these are supplementary angles. And of course this is going to be 180 minus A as well. So before we even start talking about parallel lines, we figured out 4 of the 8 or 3 of the ones we didn't know from one that we do know. Okay, what else can we deal with? Well, we have this idea here called corresponding angles. Now, what that means is that this angle here is the same as this angle here. Why? Because they correspond. When we compare this parallel line to this parallel line, they're in the same position. They're in this corner, they're in this corner. Corresponding angles. Let me tidy this up a little bit. Perhaps it's a little clearer with all that other junk out of the way. This angle is the same as this angle because they're in the same positions. Now, if I were to call this angle B, we can say that, well, one of these corresponds to angle B, and it's this one here. You can see this one's above and to the right, above this line and to the right of this line. This one's above and to the right, so they're the same as well. Now, if we were to look at another angle here, let's call this one angle C, then this corresponds to this. It's above and to the left, this one's above and to the left. They're going to be equal to each other as well, and I might be running out of colors here, but we'll try. This one's D, and of course this one's D. It's below and to the left. It's below and to the left. So that makes it our corresponding angles. So we can say the corresponding angles are in the same position on each line. They are equal. And we can draw two little parallel lines here, transversal, and we can say that these are the same as each other. It's kind of like a coded reason. Now you might have heard this called like the F rule before. I don't find it overly useful. Some people say that like when you look at the transversal and this line and this line and this, you can see a letter F. I don't find it useful. Now, of course, as I said, this goes for anything, any parallel lines in a transversal. So here we can see that this one corresponds with this one. This one, we'll call that A. This one corresponds with this one. This one corresponds with this one. And of course, this one corresponds with this one. They are in the same position on each of them. Let's start talking about corresponding angles. Now the next one we need to talk about are co-interior angles. Now what that means is that if you look at this is a parallel line, I should have put my arrows in here, parallel lines in our transversal, and then we look inside, like imagine someone's like cut this box out here. If we look inside the parallel lines, we see these two which are called co-interior, co together, interior, inside. So they're together here, these two will add up to 180 degrees. Now, even if you didn't know the co-interior rule, you could figure it out because you knew the corresponding rule. You knew that A is the same as A. And if you know that A is the same as A, you can then see that A and B are supplementary angles, which would also mean that they add up to 180 degrees. So co-interior angle, the idea of co-interior angles, is just the same as the corresponding angle idea with the extra step of finding that supplementary one there. Now, of course, it can work on both sides of this. So if this was C and this was D, C plus D would add up to 180 as well, because they are also co-interior. You can see two parallel lines in the transversal. They are inside of that, so they are also co-interior. Again, it doesn't matter how your parallel lines are drawn. If these are my parallel lines here, two parallel lines in my transversal, so these will add up to 180. Two parallel lines and my transversal, so these would also add up to 180. Those are our co-interior angles. Now, sometimes people call this the U rule, because I guess they see a kind of U here. Again, that's less useful than the F rule. Finally, we come to alternate angles. Now, alternate angles, this one's often called the Z rule, and this is one that you might actually find useful, but then it starts to trick you up, so maybe you won't find it useful. But let me talk you through alternate angles. First, I'm going to draw this one in here. I'm going to call this angle A. Now, let's give it a position, right? We're going to say it's under the parallel line and to the left of the transversal. Under and to the left. Now, this one is going to be over the parallel line and to the right. It's the opposite position. It's the alternate position of this one here. Under and to the left, over and to the right. These are equal. Alternate angles are equal. And we can do this for any of these angles and call them the alternate angles. So we can say that this angle is under and to the right, B, and we can say that this angle is over and to the left. Right, so opposite position, alternate positions. Okay, so you can see, I think, why this is called the Z rule. If we draw our line in here, we get a Z. Z, the internal angles of a Z. Now, of course, this kind of breaks down a little bit when I draw it like this, and I call these the alternate angles, because these are alternate angles, and you can see that my Z starts to get kind of stretched out. If I were to squash it down, it would become a Z again. But again, that's why I don't really love these rules. You want to be able to spot these alternate angles. Alright, those are my three parallel line and transversal rules. We have alternate angles, we have co-interior angles, and we have corresponding angles.